Hi, today I'm going to talk about my Module 2 inquiry activity, the water filter. So I'm sure many of you were like me that when you got the materials, you were thinking, what could we possibly be doing with these? And after doing some research, we all found that we had to make a water filter. This is a great activity, especially I teach 4th grade and I teach the water cycle, and I know in the article they talked about how it's a great step forward or step beyond just teaching the 4 basic steps of the water cycle. It kind of builds on that and makes it more realistic and makes it mean something. So the materials obviously resemble the layers of soil, and I have all the layers of soil there, from humus, topsoil, subsoil, rock fragments, and bedrock. And we were sent the gravel, which was obviously the rocks, as well as cheesecloth, which could be the humus, and sand, which could be the subsoil or anywhere in between. We were also sent the alum, which is a chemical filter, and charcoal, which is more of a biological filter. So when I first set it up, and I thought, okay, when runoff happens, when water is soaking into the ground, how is it going to flow realistically? Like, what would it hit first? The rocks, the cheesecloth, the sand, what would happen first? So when I set up my experiment or my activity, I chose to put the cheesecloth on top to kind of filter out any of the big debris first. My cup of dirty water had lots of clumps of dirt, grass in it. So to kind of filter that out first. And then I thought it would go through the gravel next, which would also help to filter out, once again, the big pieces of debris. So that way we could get down to that nitty gritty and getting out the smaller things. Then I went through the sand, and then the charcoal to help filter that out, and finally the alum to kind of give it that last bit of cleanliness. So I had this all put together. You can see I have push pins in the side to kind of hold the cups on top of each other to keep it stacked. But then I realized that, actually I ran it through once with just regular water to kind of prime the materials to get them ready. And what I noticed was the color of the charcoal, while it might have been filtering water, the water stuck with the water. So my water was like a grayish, blackish color. So I clearly needed some more filtering through there before I actually went through with my dirty water. So I added 2 coffee filter layers, one here after the charcoal and one here after the alum, to just catch any other extra stuff that I could catch through it. So then I went through and tested it. You can see here is my dirty water, and on the bottom there's a bunch of dirt and grass in there, all that good stuff. This picture here is after I poured it through. That was the initial debris that was caught by the cheesecloth, so immediately I thought that was a good decision to put that at the top, because it caught all that big stuff and I didn't have to worry about that. And I do have a short video here of my water going through the filter. See, so it went through the top. It went through the gravel pretty quickly, slowly went through the sand, dripped down to the charcoal, which then dripped to the alum, and then down into the final cup there. So I did it two or 3 times. I went through it, and my water was not perfectly filtered, as you can see. I did, however, I'm always looking for some positives, so I did see a little bit of an improvement, but definitely I probably wouldn't drink it. Let's just put it that way. So if I could do it again next time, I wasn't sure about my ratios of the rocks versus the sand versus the alum and charcoal. I was not sure how much of each to put in. I'd also researched other people, other groups who have done this experiment, and they put all of them in the same container, just kind of like how it would be on the ground. So they layered, the rocks right on top of the sand instead of having them flow through different cups. So, that might be a different way to approach this or to try it. As far as the level of inquiry goes, the problem in question is definitely provided to the student, but in this case, it almost has to be. The procedure and method is mostly constructed by the student. I mean, the teacher provides the materials, but the students are free to do with them as they choose. They can put them in any order. They can use or not use whatever they, need to do. And the solution is definitely constructed by that student. So as far as the continuum goes, I would say that this is pretty self-directed. The teacher guides and gives very basic outlines of what your goal is. Your goal is to filter water, just like it does in nature, just like it does in the water, in the water cycle. So the teacher gives pretty wide parameters, but the students are kind of self-directed in how they want to make that happen. And I think that makes a successful inquiry activity or a STEM challenge is when there are multiple solutions, and there may be more than one solution that is correct. So I think that's what makes scientific inquiry and STEM, a big positive, because there are so many possible answers. If you have any questions, leave them for me in the comments. Thanks.